Video 13-3, molality, percent solution, and mole fraction.
Hey, now, this is the math stuff, the important math stuff. Concentrations. How do you actually figure out how much of a solute is in a solution? Okay, so concentrations measures the amount of solute in a given amount of solvent, okay, or solution. Now, this makes a difference whether you're talking about the total solution or just the solvent. Okay, so a whole bunch of different ways to do it. So first way is to define something called the mole fraction. Okay, and when you talk about mole fraction, there's always two mole fractions. One will be the mole fraction of solute. The other one will be the mole fraction of solvent. Okay, so you have at least two of them. Okay, so A can be the solute or solvent, doesn't really matter. And B has to be the other one. So if we call A the solute, B has to be the solvent. Okay, and note, when you add up fractions, and do not express your answers in fractions. Always change your fractions into decimals. Okay, all the fractions, the sum of all the fractions have to add up to 1. So, try a little problem. Okay, what's the mole fraction of calcium chloride, and what's the mole fraction of water? You have to come up with 2 when they ask you for what's the mole fractions. Okay, so first thing you need to figure out, what is the formula for calcium chloride? Okay, and you should know by now calcium chloride is CaCl2. Okay, and water obviously is H2O. So you have 5.00 grams of calcium chloride, 100 point, which means you have 3 sig figs, grams of water. Okay, looking back at the formula, it's moles over moles. Okay, so first step, change your 5.00 grams of calcium chloride into moles of CaCl2. Second step, go and change your 100 grams of water into moles of water. Okay, so stop the video, do your calculations, and come back. Okay, if you did that correctly, this should come out to be 0.0451 moles of your calcium chloride, and the water should have came out to be 5.55 moles of your water. Okay, so if you want to find the mole fraction of calcium chloride, that means you have to do moles of calcium chloride over the total moles. Moles CaCl2 plus moles of H2O. Okay, and you also have to do the other mole fraction of water. That's going to be moles of H2O. And notice the denominator is the same thing. So once you find the moles of calcium chloride plus moles of water, denominator will be the same. Moles of CaCl2 plus moles of H2O. Okay, so stop the video, do your calculations, and see if you came out with the right answers. Okay, this one you should have came out with 0.00806, proper number sig figs. Okay, and notice, no units. All your moles cancel out with the moles down here. Okay, and this one, you should come out with 0.992, proper number sig figs. Okay, another way to do it is called percent solution. Okay, a lot of times biologists talk about doing stuff in percent solutions mainly because they don't understand the concepts of moles. Okay, now, one problem. They said a lot of times people will come up and say, "Oh, I need a 25% sodium chloride solution." Well, a couple different ways you can make that, so it's hard to figure out what they want. Okay, it could be 25% by mass, or it could be 25% mass over volume. Okay, now if the solute is liquid, then it's almost always going to be by volume. Okay, what's the difference? percent mass over mass. That's what the M and the M stands for. So you need to know what is the mass of the solute over the total mass. And don't forget, the total mass basically means you're talking about the mass of the solute plus mass of the solvent. Okay. Now, if it's mass over volume, and you have to be told, is it percent M over M or is it percent M over V? And again, you're going to do mass of the solute, just like what you did over here, same as the mass of the solute, but over volume, it's the volume of the solution, and it has to be in mLs. So if they give you volume that's not in mLs, change it. If they give you a mass that's not in grams, change it to grams. Okay. Watch out for this part right here. When they talk about total mass, this basically breaks down into this top equation. Mass of solute over the mass of solution is mass of the solute again, plus mass of the solvent. Okay. And notice these two things are the same. Okay. Now, if they tell you it's a volume over volume, solute has to be a liquid, and obviously the solvent has to be a liquid too. So volume of solute over volume of solution. Okay. And in this book, all the percent solution problems are M over M. Whoops. Are going to be M over M, which means go back and use the first formula. Okay. Now, the most important one, the one that you are going to use the rest of the entire year. So make sure you understand this concept. Okay. So, molarity. It is dealing with moles. Okay. The reason why we use molarity a lot is because you know you can change moles into a whole bunch of different things. Okay. Now, it's moles over liters. So remember this formula. Molarity is equal to moles over liters. Always, always, always remember this formula. Okay. Now, whoops. And you can always solve for moles also. Don't forget. Moles are equal to molarity times liters. And again, make sure it's in liters. Okay. Units for molarity. Moles over liters. Okay. Now, when you make up a solution with a specific concentration, you cannot just simply add solute to the desired amount of solvent. Okay. So if I said, well, go make up a 2.50 molar solution of NaCl. You cannot simply go and say, okay, well, I'll just go weigh out 2.50 moles and add it to 1 liter of water, because your final volume of the solution will not end up being 1 liter. Okay. The solution's volume will change. So you have to get your 2.50 moles of sodium chloride and add water to it until it gets up to 1 liter. How do you make a 1 liter make 1 liter of a 1.0 molar ammonium nitrate solution? Okay, whenever you see M, this basically says molar. Okay, well, first of all, look at our formula. Molarity is equal to moles over liters. Okay, what things do we know? We know the molarity. Okay, and we're going to make a volume of 1 liter, which means I don't know moles. Okay, and remember, moles is equal to molarity times liters. Okay, so we can figure out how many moles of ammonium nitrate. Again, going back to making sure you can write formulas. Okay, so ammonium nitrate, write its formula. And you should have ammonium NH4 NO3. Okay, and if you can't write your formulas, you need to go back and review stuff from chapter 7. Okay, so your moles of NH4NO3 simply going to be equal to your molarity, 1.00 molar times the liters. It's 1, so that's basically an exact number. Okay, which basically means you need 1 mole of ammonium nitrate, NH4 and O3. Okay. Now, little problem, you can't weigh out moles, you can weigh out grams. So go figure out the molar mass of ammonium nitrate. Okay, in other words, change this into grams. Okay, and you should have come out with 64.052 grams of ammonium nitrate. Okay, now make sure you answer the question. How do you make it? Well, we need this amount of grams, and you cannot add it to 1 liter. So add water to it until the volume gets to 1.00 liters. Okay, you cannot add 1 liter to it because the final volume will not be 1 liter. Add water to it until you get to 1 liter. So obviously you have to put this into a container that has markings on the side of it, like a graduated cylinder. Okay, how do you find the molarity of something? 755 mLs of solution, and it has 35.5 grams of ammonium nitrate. Okay, well, what do we know? We are looking for, and again, our molarity formula, moles over liters. Okay, we are looking for molarity. So this is the one we don't know. Okay, you got 35.5 grams. Well, you can change that into moles. Okay, 755 mLs, change that into liters. Okay, so try this problem. First step, 35.8 grams of ammonium nitrate. Okay, use your dimensional analysis, figure out how many moles that is. Okay, stop that. Stop the video and do that. Okay, if you did it, you should have came out with 0.559 moles of ammonium nitrate. Now plug it into our formula. Okay, and we also need to divide by volume in liters. So 755 mLs is equal to 0.755 liters. Okay, so molarity, 0.559 moles over 0.755 liters. Okay, and what do you come out with? Okay, you should have come out with 0.740. And the units are either moles over liter or molar. Okay, now dilutions. This you will actually do in the next chapter, which is why you need to make sure you learn this. Okay, when we get to the next chapter, you guys are all doing an activity on this individually. Okay, now when you dilute a concentrated solution, the moles stays constant. In other words, take a beaker that has a certain concentration, add more water to it. Okay, the molarity will change. Okay, and the volume will change. But what stays constant is the amount of solute. Okay, so the moles that were in the solution before you diluted it will be the same as the moles afterward. Okay, now don't forget, moles are equal to molarity times liters. Okay, so the molarity of the concentration of this solution, this part of the solution, times the volume. Okay, this is L1. Whoops. Okay, will be equal to the new molarity times the new volume. This is basically going to be L2. So if you want to find new molarity, you know this, you know this, you know this. You can find M2. Okay. Now, because a solution is homogeneous, if you pour off some of it, you remove moles of the solution. Okay. And the moles removed are directly proportional to the volume of the solution. So in other words, okay, if you have a solution that's that big, and then you pour off, let's say, 20% of it. the number of moles in here will be equal to 20% of the original. Okay, so if this had, let's say 3 moles, the amount of moles that came out of this is 20% of 3, which is going to be 0.6 moles. Okay, so how do you make a 2 liter, or make 2 liters of a 0.350 molar potassium iodide solution if you start with 1.25 molar potassium iodide solution? Okay, now, nice thing about this, you don't need to know what the formulas are since we're only looking for volumes. Okay, so potassium iodide, though, figure out the formula anyway. Okay, it's Ki. So, what are the things that I know? It's a dilution problem, so we know M1 times L1 has to equal M2 times L2. Okay, so we are going to make a 2.0 liter solution. This right here is L2. Okay, and this is the concentration of that solution. So this is going to be M2. Okay, this obviously then must be M1. So what am I looking for? New volume, which is L1. How much do I need to use? Okay, so write out what these things are. Okay, M1 is 1.25 molar. Okay, L1 is what we're looking for. Okay, M2, 0.350, and L2, 2.00. Okay, so solve for what we're looking for, L1. Okay, so L1 should be equal to M2 times L2 over M1. Okay, plug your numbers in and calculate. Okay, and you should come out with 0.560 liters. Okay, it's what? 0.560 liters of the 1.25 molar Ki solution. Okay, well, what are you going to do with this? If you just take 0.560 liters of that solution and don't do anything with it, its concentration is still 1.25 molar. Okay, now what do we need to do with it? Well, it's a dilution problem, which means you have to add water to it. Okay, so we're going to use 0.560 liters of the 1.25 molar Ki. Now, how much water should I add to it? Well, the final volume has to be 2 liters. So, 2.00 liters minus 0.560 liters tells you how much water you need to add. And that should come out to be 1.44 liters of H2O. Okay, so how do you make the solution? 0.560 liters of the 1.25 molar Ki plus 1.44 liters of water. Okay, now we have another one that comes up, molality. Watch your symbols. It makes a difference if you use a capital M or lowercase m. Okay, molality is moles of solute over kilograms, not of solution, but just the solvent. Okay, note, if you have a molarity solution, it's not the same as molality. Okay, why? Well, go figure it out. If you had a 1.00 molar solution of sodium chloride and 1.00 molal solution of sodium chloride, do they both have the same amounts of solute and solvent in there? Okay, how do you make a 1 molal solution of sodium chloride? In other words, how much solute, how much sodium chloride, how much water? Okay, well, you get to make any amount that you want. So, since molality is equal to moles over kilograms of solvent, and we're going to use kilograms of water, all you know is that this has to be equal to 1. Okay, so Make it easy on yourself. Make that 1.00 kilograms. Okay, which means this up here should be 1.00 moles sodium chloride. Okay, so how do you make it? Well, you need 1 mole of sodium chloride, but you can't measure out moles. So 1.00 moles of NaCl is equal to, go figure it out. Stop the video, come back. Okay, simply 58.44 grams of NaCl. Now, what do we need to do with it? This is when it gets easy. You just simply add 1 kilogram of water. Okay, and you now have a 1 molal solution. So here's your review question.